Welcome guests, thank you so much for coming today. This series is sponsored by the Data Institute, which is the umbrella organization for all data science and data engineering programming and research that happens here at the university. Please join me in welcoming our speaker today, Shubham, a data scientist at Nordstrom, place I've spent some time. Often online, specializing, so he's at Nordstrom, specializing in large-scale AI solutions. So he no doubt has my data. With past roles at Amazon and HealthTap, he brings deep experience in vision language models, LLMs, and generative AI. Today, he'll share how models like Clip and FLAVA are transforming digital shopping, boosting engagement, and improving product discovery at scale. So I'll hand it over to you. Welcome.
Hello. Hello everyone. Super excited to be here. Today I'm going to talk about two really interesting problem domains. First is AI-powered style filters. You can see an example of that here. We have a product and we have to predict relevant location values like cocktail and party, vacation, casual. And second domain is attribute collection. And here is an example of that as well. We have a product which is clearly a bottoms, but was marked as tops in our product catalog. So we have to create a system that identifies such products and cuts their attributes. Before I go into the details, here is a little bit of me. I think it was already discussed, but let me repeat it again. Previously worked at Amazon and HealthTap as a software engineer, focusing on ML and AI projects. Did my master's from Cornell University in computing and information science. I love working in technical side projects, reading in general, playing pool, table tennis, and so on. This is my LinkedIn. Feel free to get in touch with me anytime. Here's our agenda. I'm going to start by discussing AI-powered style filters. I'm going to discuss the business problem. We'll focus on occasion category and women's dresses for dialogue to be specific. Then I'm going to talk about the technical solution and the results. And then I'm going to talk about the second problem domain, which is attribute correction. And I'm going to discuss that same problem domain in a similar fashion as I discussed the first problem domain. And then we can go ahead with Q&A after that. So here is a quick screenshot from Nordstrom website to give the audience an idea of what occasion filters look like. Customers land on this page and usually click on relevant occasion filters and buy products. As you can see, products shown rely heavily on how well the occasion tags are assigned to these products. So let's discuss why these style filters are so important. Well, first is that they help in establishing a deeper connection with our customers. Usually customers have an occasion in mind when they land on Nordstrom page, and they, for example, if they want the summer vacation dress, they click on the filters and platform shows some really good options. And it's a way of saying to the customer that we understand. And now among all style filters, occasion enjoys a special place. It has one of the highest attributable demand. Women's dresses account for majority of this dollar demand value, and it's extremely subjective and hard to get it right. Hence, the old system we used had a lot of opportunities for improvement, both in terms of increasing the attribute coverage and the attributable demand as well. So keeping that in mind, I'm going to talk about a novel system that is not only scalable, accurate, and replicable, and it also truly captures the meaning of fashion-related concepts. In a way, it allows us to define a playbook that's applicable to not just dating, but to other filter categories as well. Let's talk about what attribution coverage means here. We see a line dress here. In-house experts assign cocktail and party and date night as a location tags to this product. Old system unfortunately did not assign any location tag to it. So this leads to multiple problems. First, this is inaccurate. Second, this hurts the attributable demand as well. You may ask how. Well, these are the occasion filters that are shown on the website, and this product won't show up if the customer clicks on the cocktail and party or bikini. And fortunately, our new system correctly assigns both the occasion tags. Let's look at another example. Here we see a rib tank dress. Our in-house experts assign casual and date night to it. Old system, unfortunately, just assigned casual to it. And this again leads to multiple problems. First, this is inaccurate, and second, this hurts the attributable demand as well. So again, this product won't show up if customer clicks on, say, date night filter. Fortunately, our new system correctly assigns both the occasion tags. So, given this business problem, here is the solution that combines AI models and knowledge of the fashion experts. What we do first is we redefine the way fashion experts' knowledge is captured for subjective attributes. I think this is the most crucial step. Next, we redesign how AI models are built. And together, in a way, this allows us to encode fashion-related concepts into the model. Not only that, the whole process is designed in such a way that it is scalable and replicable. And while it leads to improvements in occasion filter, the same can be done with other attributes such as style, activity, etc. Whether it is subjective attribute or an objective attribute, this process scales pretty well. So now let me discuss how we redefine the way experts' intelligence is captured. As I mentioned earlier, this was the most crucial component in my opinion. So occasion filter categories, as I mentioned, is pretty subjective in nature. And with single product being reviewed by only one expert, we don't really get the comprehensive insight that we needed for the particular product. So to resolve this, we built a mechanism where instead of just one expert, multiple experts can view single product. And this allows us to gain a holistic view of occasion attributes. Here is a screenshot of the application that we built to collect all the knowledge of fashion experts. It shows the product info as if it's a product detail page. There are images for different colors, text info, and then relevant labels on the right hand side. Experts can look at the image on the left, look at the text, and select relevant labels and submit their feedback as well. Now let me discuss the AI model training part. The model training involves fine-tuning OpenAI clip model. We used pre-trained backbone by utilizing the clip model for feature extraction. The backbone is frozen to leverage the pre-trained visual embeddings. And in the embeddings and the fusion stage, we have a CLS token that serves as learnable embedding to summarize multiple images. Additionally, fusion layers use transformers encoders to combine these embeddings. Finally, in the output and the classification stage, the classification head maps the fused embeddings to multi-label predictions, providing probability scores, which we can turn into occasional labels later on. On the right, the diagram outlines the model flow, input multiple images, process through the backbone to generate image embeddings, and so on. I can later on discuss this diagram separately and zoom in a bit as well. So let's discuss the training approach. Our objective is to predict occasion labels from multiple product images. The trainable components included the CLS embeddings, fusion layers, and the classification head. We use loss function based on binary cross entropy for multi-label classification. And overall, this whole approach had several advantages to it. First was that the pre-trained features allowed us to obtain robust feature extraction from clip model. And then the multiple image capability enables effective aggregation of information across images. Here is the model performance compared to our baseline model. So we saw an improvement of 30 percentage points in the macro recall compared to our baseline model, which was a very simple zero-shot clip embeddings plus logistic prediction. And we also observed increment of 11 percentage points on macro precision with this new approach over our baseline model. So these improvements positively impact the attribute coverage while maintaining a high precision, which is something that was very important to us in our business problems. I like this slide a lot because I was able to add the evaluation results from before vision zero shot as well. We saw improvements with GPT vision zero shot as well, especially in the macro precision. But overall, the OpenAI clip finding model did better than both these approaches. Here are some more examples. You can see experts assign casual to this product, and our new model assigned casual to it as well. Our baseline model did not assign any label to it. There is another example where labels assigned were night out, formal, cocktail and party, and our new model was able to assign night out, formal, and bridesmaid for some reason. And then old model only assigned formal. So that was about the first business problem. Second problem domain is attribute correction, and I'm going to follow the same pattern of discussing the business problem first, and then I'll focus on the product type attribute correction, then on the technical solution, and then the results. So here is the same example that I shared earlier. So why do we need attribute correction? Let's discuss that. We usually have a vast ocean of live products. If you look at any retail company in general, and products with wrong attributes hide somewhere in that ocean. And finding such products is like finding a needle in the haystack, and it's a very time-consuming process to find such products, and there is usually no automated way to do this. And that's where the attribute correction comes into the picture. It's an efficient way of finding products with incorrect attributes and suggesting corrections as well. As you can see, there are two pretty cute examples here. On the top, we have an item that was assigned bottoms. Clearly, it's a top. Below, we have an item that was assigned sweatshirt. And clearly, it's a t-shirt. So, still, why do we need these sections? There has to be some business value associated with it. Will these sections usually lead to missed sales opportunities? Look at these products, we have a short swim top and a skirt. But when we apply appropriate filters, they are not visible to our customers. The reason is that they have been assigned wrong product types, and this leads to potential demand miss of around $500. And this is just for these 3 products. And that's a big miss. This can cost millions to the organization. So, given this business problem, let's discuss the solution that combines again the AI models and the knowledge of fashion experts. Solution in this case involves training models that take in product info like text and image as input and predict attributes like product type in this case, because that's what we are correcting. In this case, we fine-tuned FLAVA model on the Nordstrom product dataset. An original FLAVA model was developed by researchers at Meta. The models we fine-tuned had amazing accuracy in identifying these attributes. Since they were so good at identifying these attributes, they can easily be used to suggest corrections or used to find products with incorrect attributes as well. To find items that require correction, we start by inspecting the model results itself. As I mentioned earlier, models have very high accuracy, but there are cases where models are incorrect. And these cases usually fall into these scenarios. One where the assigned label is wrong, and the second being where the model is truly wrong. And we have lots of examples that fall under the first bucket. And this is where the opportunity lies. Finding such opportunities essentially involves looking for relevant mismatches. Relevant mismatch is essentially where predicted product type is not equal to the assigned product type and model is super confident about its prediction. This equation shown at the below gives us the examples like the product I just showed here in this slide. This is clearly top assisted by a model, but it has been assigned bottoms. So these relevant mismatches gives us a list of products that require correction. It turns out that the list of relevant mismatches is pretty huge. So we also utilize GPT-4 to further strengthen the list of products that should be corrected. What we did was we passed in the text and the image of the model, image of the products to GPT-4, and then also passing the assigned label and the label that was predicted by the model. And we asked GPT-4 which label it agrees with. And that gave us way better list of products that should be corrected, where we are super confident that these are the products that should be corrected. Here are some interesting examples. As you can see, the assigned product types are all wrong. Our process suggested correct product types from all these 3 products. Here are some more examples. As you can see, assigned product types are all wrong. And our process suggested correct product types for all these 3 products. This is an interesting example. Wrong attributes also negatively impact other key business processes. Here you can see this product was tagged as brands. And because of that, look at the outfitting ideas that were shared in the page. And it consists of two tops and no pants. And that looks weird and funny.
Good outfit.
And so because of this process that we introduced, we were able to make these corrections, and now the outfits make sense. So it kind of hitting two targets with one row. That's it. Pretty quick.
Does anybody have any questions? If you do, you can line up at the microphone. Victor's gonna set it up and maybe start with a question.
Whoa, it looks
disgusting.
Hi, Shubham. Thank you very much for the presentation. I had good questions. For first model that you showed us, you said that you guys used the experts to kind of label your data. I was curious about what would you have done if your manager said, no, we're not going to go about doing that. What were some alternatives to think about?
Yeah, I thought of two other approaches. One was using the customer click behavior to obtain label data and then try to create a model out of that and see how that goes. The second approach, I was thinking of doing a distillation approach where I will generate a data set by tagging it using GPT-4 and then see and combining it with some whatever human label data we get and then see how it goes.
How long does the labeling process take and cost?
So we had 4 people who were spending an hour or so every day. And we were able to live around 2,000 data points. And it took around, and that was not their only work, they were pretty busy with other stuff. And so it took around a month or so for them to
Right. And my last question was for the second model that you showed us, you said that you used GPT-4 to kind of choose between the tags that were available, one that was spent on the model, one that was the previous old tags. How did you go about validating what GPT-4 was shooting?
we prepared a small data set and verified the tags selected by GPT-4 and then shared it with the team who could verify the tags generated by the GPT. So we did the evaluation process with humans once, and then we decided to do it every month to make sure that the correction that is done by GPT-4 also makes sense.
Do you know off the top of your head how accurate that was?
It kind of matched the accuracy of finding model itself. But again, the accuracy number matched, but that does not mean that the same number of data points were shown to GPT-4 compared to finding model.
Thank you very much.
Hey, thank you for your talk. My first question is about the first model that you made. I know that the labeling is an important part, obviously, for all the reasons that you've said. And I was wondering, you have the experts that are making these dresses and making these fashion items. Don't they come out labeled when they're going through the process of being made?
Apparently that was not the case. So usually there are, if you look at the product attributes, they usually fall in two buckets. One is objective set of attributes, which is like product type. So like I would say four attributes, like size, color, material. Uh, Occasion really does not fall in that. In fact, so sometimes we get the values for some products, sometimes we don't get the values for some products. So that's why we have to come up with a ML to generate attributes.
Thank you. And I just have one more question. When we found all of the misclassified or the tags that were incorrect on all those clothing items, did you run an analysis to see if they were like selling under your predicted like sales amount? Because you had said that they were back to sales and they were mistagged, and I was wondering if you had like verified that.
I'm not understanding the question.
Sure, so you have all of these clothing items that are mistagged, right? I was wondering if you had done an analysis to see, okay, all these items that are mistagged, they're actually selling at a lower rate than we predicted. Was that the case that you found, or did you do that analysis, or you didn't do that?
So we did that analysis to convince the stakeholders that this is the time, this is the business process we need to institute. Otherwise, we are going to miss some. We are going to have missing sales opportunities, and only then we were able to kind of work and invest time in this project.
How did you convince them to do that? Do you have a predicted sales amount for any given item, and you saw that you were not hitting that target? Or are you comparing it to other items?
So there are for custom models that allow us to understand how well should different segments do, and that kind of gave us an idea of, okay, this is the section we should probably look at least look at the data.
Thank you so much.
Hi, thank you for the talk. I was curious. Sorry, I forgot. Yes, I was wondering when you have those experts look at all the data points, is that something that you're continuing to have them do as you're monitoring the model? And I guess the reason I ask that is as new trends come in, how does the model do on those guesses?
Yeah. If you look at Nordstrom, they have two pretty big events across the year. One is the anniversary sale, and then there's the New Year sale that happens. And then there are people at Nordstrom who keep seasonality in mind as well. So we discussed with our experts at what time they would be comfortable reviewing the results of the vocational models. So once we agreed on the number of times they would like to review the results, we used to use the same application that they use to tag the products. We used to present the predicted labels in the same way in the similar application so that they can give us a feedback on how well the models are doing.
Thank you.
Could you go to the, sorry, thank you for your talk, first of all. And can you go to the slide where you show the GPT vision versus your fine-tuned model versus just the regular? I think you had statistics on that for precision, et cetera. Yeah. For this one, right, what are the prices, or rather the costs to the company to do these three different options? And then are they worth the outcomes that you're getting? So is it, 7.4, is it worth it to get that 81 in that one field, for example, versus cost?
Yes, so let me discuss how much it takes to serve the model. So OpenAI Clip fine-tune was trained on a P2X large, just one GPU. It was pretty cheap. And also the predictions in production, predictions can be done offline. They don't have to be done on real-time basis. And for GPT-4 Vision Zero Shot, for that two cost was not that much compared to fine-tune model. But since the performance was pretty decent for OpenAI with fine-tune, we decided to go with OpenAI with fine-tune. Also, I should also say for GPT-4 Vision Zero Shot, we just did one couple of prompts and experimented with a couple of prompts and then observed the results. And I kind of feel if we had spent way more time on just trying out a bunch of prompts, then who knows, probably performance would have been better.
Thank you for the thought, but that was actually my first question. Is, what level of prompt engineering have you done to get to these results? Because obviously, there's a lot of different techniques used to improve these prompts. And then my second question is, like, in terms of these models, I mean, you're still looking at like 81% precision. I mean, it's good, but like you're still not capturing labels, a significant amount of time. So, like, have you looked at other models? Have you looked at the possibility of like stacking models or ensembling models?
Yeah. So, first question is about prompting. We just did very basic one-shot prompting, no chain of thought, things like that. Very, very simple. If this was my pet project, I would have done that, but we had to hit a deadline. And then, so I had chalked out, these are the experiments I would do. We as a team, and then we'll figure it out which one works best. And then we'll, whatever model strategy works best, we'll be able to go forward and in production. So that's about the prompting step. Regarding fine-tune, we had tried very simple fine-tuning strategy of the same model, but with no fusion layer involved in it and no transformer layer in between, which I mentioned in this slide. There were no fusion layers in that. That did not work that well. And then when we included fusion layers, we reached this performance. And I'm pretty sure if we experiment with the strategies that you are mentioning, like stacking, I think we would be able to increase the macro recall a bit more. But we did not get the chance to do the experiments, to be honest. Thank you.
Hi, Shubham. Thank you for your talk. I was curious, when you were going through these images, was there any work done for like segmentation of the outfits or controlling for like the models wearing the outfits, or was that maybe like a feature, like part of the design, like how much skin was showing maybe, or did you leverage that to help create these tags, or is that something you had to overcome?
The only selection strategy we did while selection strategy while selecting images was at the time of collecting the data itself, but not at the model training step. We decided, first of all, we decided that we are going to be a bit more holistic. That is, we are going to cover multiple colors given the product. So we selected 2 images per color for this model, and that's the only data selection strategy we kept in mind. And then there are different shot types assigned to the image that are shown on product detail page, like frontal, side, zoomed in. So we removed some of the shot types which we felt that they won't be important for predicting which location should it be. Like there were images which were side angled, which we thought probably won't give us any important information. So we removed that. And then there was a zoomed version of the cloth of which we removed from our data set. If we were going to create material classification model, then probably I think zoomed image might be the. So, but in this case, we just did that solution.
Thank you very much.
Thanks. And thanks for opening this up to the public. I just was by, so I just jumped in. I just wanted to understand the output a little bit more. So for each image, were you outputting like one class, or did you output like say 3 classes and I can pick maybe if the answer was correct, maybe something like that. Just like that's just a bit nuanced. Business casual, you tweak it a little bit and it becomes like probably something else. And then could you do any interpretability to understand like what the model, like why the model is like doing outputting like this outputting, and also understand like the location graph, like sort of like how close are some locations to each other. So just to give you guys that more rounding.
Yeah. Let's start from the labeling strategy. So location problem is multi-label problem. So more than one label can be assigned to a particular data point. So we use we kept it pretty simple. We use the threshold of 0.5 for every label, and wherever the probability for that given label was greater than 0.5, we selected that in our final answer. And that's where these results come from. And then the second problem is multi-class problem. So in that case, only one label will be assigned to that particular to a given product, because it can either be tops or it can be easily bottoms. So the label that had the highest probability we selected that in that case. And then when you're talking about interpretability in that case, so we internally use weights and biases for our model training. We did use their experiments feature to understand the results of different runs and how well which labels usually are predicted together, which labels are predicted usually not together, things like that. For example, there are some dresses which sometimes had similar kind of labels, like bridesmaid, cocktail party, things like that. So that was the analysis done using weights and biases, and then there was some probabilistic analysis done as well, using the results from weights and biases.
feel like it's very unfair. Y'all tricked me. Thank you so much for that talk.